Hi everyone, my name is Anurag Goel, and I'm the founder and CEO of Render. Render is a modern cloud provider focused on developers and on the developer experience. Today, I'm excited to talk about the evolution of developer experience in the internet age and how it has changed over the last 2 decades. We're going to go over the various eras of developer experience since we started building dynamic apps for the internet. DevX for static hosting has generally been fine. Dynamic content is where application needs strongly influence both development and deployment. We'll look at how things were great with LAMP, then not so great with enterprise Java, then better again with Paas 1.0, and then worse with Kubernetes and containers. And finally, I'll talk about why there's cause for optimism. So let's dive in. In the mid to late 90s, the internet was the Wild West. These were the days of dial up, of bulletin board systems, and of AOL spamming everyone with get online disks. And much like the Wild West, you didn't really need a permit to do things. In other words, developers could simply deploy code. It was made easy by the Common Gateway Interface and the LAMP stack, which stands for Linux, Apache, MySQL, and typically one of PHP, Perl, or Python. The developer experience here was great. You wrote your code and FTP'd it to your hosting provider, who ran Apache for you, and your changes were instantly picked up by the next HTTP request because Apache ran your code on every request. So why didn't this stick? The biggest issue was performance. Spawning a new process for every HTTP request was clearly expensive. And because everything was a short-lived process, you could not reuse things like DB connections or in-memory caches. The next big problem was security. CGI scripts accepted form input through environment variables, so they were really easy to exploit. Just imagine letting anyone on the internet set environment variables for your server-side code. Not wise. Finally, it was hard to test and to debug CGI applications because your local development machine could not replicate the cloud environment that they ran on. So, in the end, enterprise businesses abandoned LAMP and went a different route, which brings us to the rise of enterprise applications. In the late 90s, Sun released Java, a free and open source runtime environment and language that could run anywhere compared to the not free Microsoft stack. But Java didn't just catch on organically. Sun spent $500 million on a massive Java marketing campaign with Christina Aguilera as a spokesperson. That's her right there in a Sun Microsystems ad from 2003 on her Java-powered cell phone. Sun did this to counter the rise of Microsoft and Intel. They were in the business of selling servers, and promoting Java was their way to take developers away from Microsoft and make more applications run on Sun infrastructure so they could run more servers. But Java, and especially enterprise Java, wrested control away from developers. In this world, you wrote code, added it to version control, and just waited. And on your development machine, you ran these massive enterprise Java servers, which took forever to reload your code. And you use editors like Eclipse, which were memory hogs. So in general, it just wasn't a fun experience. At the same time, engineers had to get trained in not just server management, but also in running enterprise Java servers like WebSphere or JBoss. All of this meant that application developers were completely dependent on someone else to deploy their code. and this led predictably to slow development cycles. This phase also created barriers to entry for startups because you had to buy expensive hardware and rent space in a data center to run your applications. So, just in general, things were bleak, and uh, developers, engineers naturally did something about it, leading to virtualization and platform as a service 1.0. It started with the Zen hypervisor, which was released in 2003. A hypervisor is used to manage virtual machines, which were made mainstream by VMware earlier in the decade. And Zen did it with good performance and enough isolation to use for shared hosting. So it's no coincidence that AWS launched EC2 just 3 years later and used Zen as the foundation, at least in the beginning. Early EC2 gave power back to developers. No more waiting for someone to buy and provision servers, just create a VM with an API call. EC2 also made accountants happy because it transformed capital expenses on servers to operating expenses on AWS. This was crucial for startups and big businesses alike. But AWS itself was never really meant for application developers. It was always meant for server administrators. And that's where Heroku comes in. When it launched in 2009, Heroku was far ahead of anything and everything in its category. Pushing code to Git to automatically deploy Rails apps was just magical. And we saw similar innovations with Google App Engine, with Firebase, and Paas. Still, things weren't quite perfect. In fact, far from it, because all the past providers in this era struggled with inflexibility and with meeting the demands of complex applications. As an example, none of them offered private networking or disk storage, which meant you could not run tools like Elasticsearch or Hadoop on them. So this forced enterprises to adopt AWS at scale, and perhaps as a result of that, Heroku and Paas and Firebase all ended up selling early. They did not deliver the mega exits that VCs were looking for, and thus began the long past winter, along with previously unseen levels of complexity, which brings us to today. Containers and Kubernetes and 10x complexity is where we are right now. And it's not great. And this is why we have this conference, and this is why we're at this talk. So in 2006, Google released their work on C groups, which made it possible to control resource usage for a group of processes. And then C groups combined with Linux namespaces became what we now know as LXC, or Linux containers. Then in 2013, Docker made containers actually usable. Docker was created by a company called .cloud, who were building a platform as a service to overcome some of Heroku's limitations. Now, that platform itself wasn't a success, or at least a runaway success, but Docker was, and much more so. So they renamed the company to Docker in 2014 and decided to focus entirely on the Docker ecosystem. Right around then, AWS was also using containerization or micro VMs to build Lambda, which was sort of like CGI 2.0. But the big innovation there was around pricing. You paid for Lambda by the millisecond and only for the time your code was running. Finally, also in 2014, Google was getting ready to release Kubernetes. And this was built to manage large fleets of containers, and it was inspired by their own internal systems. As we'll see, Google helped Kubernetes win the container wars, and that led to the state we're in today. Now, these are all vendors and open source projects we're using or trying to use. And even without going into any details on this list, it's very clear that infrastructure and the DevOps industry and DevX in general has just never been as complex as it is today. So, how did we get to this level of complexity? The answer is marketing. We saw this strategy earlier in the talk with Sun and Java. Google marketing was smarter because they focused on building a vibrant community around Kubernetes and got a lot of companies to buy into the whole thing through the Cloud Native Compute Foundation. But how does Kubernetes help Google? It's quite simple. It levels the playing field with AWS because Kubernetes can run anywhere. Kubernetes also turned out to be a better product than AWS Elastic Container Service, so the industry quickly converged on it as a standard. And while Kubernetes has its warts and complexity, it is fundamentally a great open source project and a great product. What it isn't, however, is a product built with developers and local development in mind. So this is the first problem with DevX today. The other issue, of course, is FOMO. Most companies don't need Kubernetes, but they use it anyway because other companies are using it. But we're also starting to see, in addition to FOMO, Kubernetes fatigue. We're realizing that managing Kubernetes clusters is hard, even if you use GKE or EKS. Similarly, a lot of Lambda users are complaining about local development. Still, serverless itself is in its infancy, and I think we should keep an eye on it. So that covers the last 20 years, and there's clearly some PTSD, but there are also signs of new life. Developer-focused engineers are now using containers and Kubernetes to create better experiences for application developers. We're also seeing a renewed emphasis on performance with languages like Go and Rust on the back end and WebAssembly on the front end. Developers are now also driving software purchase decisions. The cloud market is much bigger and growing quickly, and all of this has increased the funding that's available for startups focused on DevX. And it's all really encouraging. Still, there are problems. Kubernetes FOMO is still real, resulting in a lot of resume-driven development. And then there's fragmentation. If you want a full stack application, you get a static site provider, but then you need a database and a task queue, and very quickly you're working with 5 different vendors who don't really play well with each other. The third issue is related. Even if you're okay with multiple vendors, there are way too many of them in almost every category, so it's very hard to choose. Still, we're making headway on these things and more, and many of the speakers at this conference are part of this new generation of developers focused on improving the state of the art and making things better for the next decade. So, what are we looking at in the next decade? First, I believe most engineering teams are going to stop using Kubernetes directly. Instead, they'll use cloud providers, perhaps like Render, that remove that complexity with a strong focus on developer experience, but also by incorporating the features that complex enterprise applications need. This also means that the DevOps profession as we know it will change. Very few companies will need armies of SREs because they're going to use cloud providers that make all of it unnecessary. Next, we're going to see big advances in workload isolation and in performance, which is amazing for DevX because ultimately it will lead to tools and to platforms that aren't even possible to envision today. So I'll end on that cheery note. And that's my talk. Thank you for listening, and thank you to the Gitpod team for letting me speak at this unique conference. I'll be around in Discord for questions. Thank you. Cheers.